Hey everyone, welcome to Introduction to Programming, week 2. So, this week is going to be a bit of a cool, as in lightweight week. So, we're going to learn a bit more. We're going to go a bit in depth on terminologies. We're also going to learn a few more methods on how to tackle issues. So, let's get on with it. So, what we're going to be learning this week is implicit and explicit typecasting, right? So what's the difference between implicit and explicit? Well, implicit means it's implied, right? So this is something that the computer assumes for most stuff. It is always safe. It is also very reliable. It's also automatic. Explicit, on the other hand, it is, we had to explicitly mention it. So what we do is the programmer manually says take this data as this type, right? And sometimes it can be risky. It's not always safe. It can sometimes be dumb. So for instance, there is a very important thing you should know about the storage values of different types. So you can store a character in a string, right? You can store an integer in a double, right? So integer is smaller data type than a double, right? I mean, if you want to go a bit more in depth, you can say that integer can be stored in a float, which can be stored in a double, right? So let's say I explicitly tell the program to store a double as an integer. That is explicit, because essentially if I have a 1.023, which is a double or a float, if I store this as an integer, what's going to happen is it will not store this value. It's only going to store this one. And this shortening, this compressing of data is known as truncating, right? So it's very important to remember that when you store a big value in a smaller type, you will always lose data, and that loss of data is known as truncating, right? So you should also realize one more thing: this can only be done by the programmer explicitly. The program will never want to make a double into an int unless you specifically tell it, explicitly mention, hey, do this, right? Because if you have a double, the computer will implicitly, or the program will implicitly keep it as a double, right? Just for safety purpose, right? And it's always automatic, it's always reliable. Whereas sometimes you have to use the explicit typecasting to, for various things. And we will be walking through an example of where we use implicit typecasting. So let us move on. Right. So we will also talk about one more important thing: double related calculations. So when it comes to doubles, right? Doubles mean there is a huge, what do you say, point value, right? When it comes to double, let's say you want to, you have a value A that is a variable double that can change. You have a value B that's a constant. What you do is you check A with B to see if it is true, to then do something, right? Now there is a huge problem if these both are doubles, because let's say you have the number 3.004, right? But you have only said double B as 3. You haven't defined it as 004. What will happen is these two are not equal to the computer. Yes, they are technically equal to us, but for the computer it's not. Hence, this will be wrong, and if our program wants to consider these two as equal, this is a very wrong condition to put. So how do we solve this problem? Well, instead of using is A equal to B, what we do is we use math.abs. ABS stands for absolute value of A minus B, right? If this is less than or equal to an error margin, so I'm gonna write it in brackets, an error margin. Now let's talk about this specifically. So math it pulls the math function. So what it does is helps us to use the absolute value function, right? What is the absolute value? Well, you don't have to worry about if a number is bigger, if A is greater than B or B is greater than A, so that you will get a negative value. Because what it does is it removes the negative. It gets the absolute value of that number. So you don't have to worry about which one of these are greater, right? So that is what this is used for. It cuts the negative off of numbers. Now, is this less than or equal to? Now, what is the error margin here? Well, you can say it like this: 0.01. You can set this is one of the many values that you set, an error margin. So if you study physics, you know that error margins are usually in percentages, but rather than percentages, it's better if you consider them like this in programming. Because here's what will happen. Let's take our previous example: A being equal to 3.004 and B being equal to 3. So let's say this is my code, right? Maths absolute value A minus B less than or equal to 0.01. So A minus B is going to make me 0.004. 004 is less than 0.01. Hence, it will mark as true. So instead of using is A equal to B, where A and B are both doubles, I can use this function because it is much more better than this function when it comes to comparing doubles. Comparing, or not comparing, if this is not equal to other. So instead of using the simple equation sign, relative operations, we can use this. Now you might wonder, how would you know how much is the error margin? Well, that depends. For money, right, whenever you're considering money values, 0.01 is best because you're not gonna get another value that is gonna be further than that. Cents are usually minimum cent you can get is 0.01. But when it comes to scientific calculations, maybe you should put 0.00001 because it's scientific. It should be accurate to a point, right? So this is all the double related calculation that you should keep in mind, right? Okay, so let us talk about something. Let us talk about strings. Okay, so the class string has some substrings that we're going to talk about. So for instance, before that, let us talk about the string itself, the class itself. So string name is in, right? So what it does is it applies an index to each and every single one of these characters, right? So capital Y is 0, simple A is 1, 2, 3, 4, so on and so forth, right? These are indexes for the string, right? And you should realize string is made up of characters or char, right? And at 0 it's capital Y, at 1 it's simple A, so on and so forth, right? So why are we talking about this? Well, let's say you have a program that wants to take every letter of this, string. Well, you can put letter, which is the name of the variable, and you can put char at. Okay, this is a subclass, a sub function inside the string class, right? And you write the index number of the string. So at 0 we'll give the letter y, which will assign the capital letter Y to the variable name letter, right? So what are the sub classes under string? Well, we have the simple one, char at, which gives us the character at the specific index. And remember, characters are always having single apostrophe, not double apostrophe like string. Next we can take length, and then we can take substring, which I have no idea what it is for, and then we can put equals, which again I have no idea it's equal for. But character at shows a character at a specific location, at a specific index. Length shows the how many letters or characters are there in the specific string. We can use this with a for loop. Now we haven't learned for loop before, but let's just go with it. So usually for loops are broken into 3 sections, right? First of all, what we do is we do the initial one. So int I is equal to 0. This is where it should start, this is where it should end, less than or equal to, it should keep on running until this, so it's better to use less than or equal to this. And then we have what it should do. So this is increment thing. So we can put int less than 5, but instead of 5, because Yazim may have 5, but what about others? Well, how about this? I is less than word length, right? So why am I not putting equal to here? Well, because if I take the word Yazim, it has 5 characters, but you should always remember the index starts from 0, so the last one will always have 4, which is less than 5. So therefore I don't put the equal sign here, I only put less than over there, right? So for this condition I can put what? System out print line, right? Well, I should actually print out something. So what we should do is word dot char at I, right? So what this will do is it will print out my name in specific lines. We can do a lot more with this. This is just an example. By the way, you don't have to worry much about for loops. We are learning for loops. For loops will be learned probably in week 3, so stay tuned. Another one that we learned was constants that is in between classes or in between main stuff. So for instance, let's say you want to set the value as pi as 3.14. It is a constant regardless of where you want to pull it in the program. So usually you will have public class driver. Now I would like to remind you that driver is the name of the file. Okay, it should always be the file name, and below that you will always have public static void main string args, right? So you'll usually have stuff inside of this. Here you can put above all of this public static final, meaning it cannot be changed under any circumstance whatsoever. We give the integer a type, we give the integer, not the integer, we give the variable a type, we give the variable a name, and we assign the variable a value. You see, under any circumstance down here, hereafter, pi will always be 3.14. I can never change it. If I try to change it, if I assign a value for pi as 3, the program will shut itself down, because this is a constant that can never be changed. This is one of those words that shows that the value cannot be changed, right? And the best part about this is that I don't have to keep on defining the value of pi every other program I make. I can make so many other public static void main 1, main 2, main 3, and what that will all say is that in under all of them pi will be 3.14. It is like a constant above constants. Next, what we learned was about libraries, right? So there are two types of libraries. One is standard libraries, that is built in Java itself, and there's external libraries which we should import from outside for instance game development, for reading stuff and all that. So a good example for standard library is the utility library, the math library, sorry, it's capital M, math, the language library. Okay, what you must know is that java.lang, the asterisk here means everything under this toolkit, the language toolkit. And there's one more important thing, java.lang, right? All of this is already defaultly imported, right? Which is why you don't have to write java.lang import java.lang on top of the program, because it's already there. But we still do this for java.utility. And we learned last week that one utility, that is the scanner utility, right? So the same thing goes for math is already imported, so you don't have to specifically import it every single time. You can immediately just go math.power as math.square root, so on and so forth, right? It's already imported. So that is all of these things, what is already important, what is not important, these stuff you learn through working with the code itself, right? And last but not least, what we learned in theory is something that we already learned last week, but I would like to officially have it here. That is the scanner utility. So again, I would highly recommend going watching Bro Codes Bro. I have no idea, but I will link his video in the description. Anyways, he teaches how nicely to use the scanner utility. So I'm going to give you a brief overview. So every single time you have to import the scanner, which all it does, it reads an input from the user, right? So what we should do is we should always import. This is before the public public class drive and all that. You have to import java.util.scanner. Remember, Java is a case sensitive program, so this S must be capital. So you're writing all the public, static, main, void, and all that. Under that, you can usually put system out print, and you can print something, and then you can usually pull the scanner. But before you do that, you have to define the scanner, right? So here's how you define the scanner. You put scanner. You can pick any name here. This is the only part that you can change. I usually pick SCN because it's simple. Then you have to write new, then you have to write scanner system dot in. The only thing you can change this line is this, that is the name you have given to your scanner. Otherwise there's nothing that you can change, right? Then you put an output, you ask a question, and then what you can do is you define a variable type, right? Let's say I'm asking for age, so age doesn't have point value, so it's an integer, right? Integer, I'm gonna write age, I'm gonna write SCN, then I'm gonna write next int, right? So to give a brief summary of this, we write scanner. Here's a name that you can apply, whatever name you want. New scanner system.in. This is something that you should do to utilize the scanner. So then what you can do is you can write a system output. Now you might wonder, as I did, sorry, not output, can't you use the scanner without the system out print? Well, you can, but the user, whoever is using it, may get confused as to why the screen is suddenly blinking. So they may mistake it as, how do I say this, as probably the program got stuck or something like that. So it's usually best that if you put a system out print and you print something, at anything at least, so that the user knows that, oh, they have to enter something, right? Then we have the variable type. We write the variable name, so that scanner name you took, you can write it here, dot next int. Now that is for integers. You can also write next float. You can also write next double. Now what about strings? Do you write next string? No, you don't. You write next line. This is a very important way to figure it out. This is like a very generalized idea of the scanner. So this is what we learned in week 2. There is definitely more to come in week 3. We will be learning apparently loops. Otherwise, this is all there is.